Hello and welcome to today's lesson on theoretical and experimental probability. This is our last lesson for this year, so please make sure that you have a notes page ready to go, as you will need to show me that at the end of the lesson. Today our objective is that the mathematicians, you all, can find theoretical and experimental probabilities. So once again, make sure you are following along on our notes page. We've got some vocabulary words, and some of these might be familiar to you. The outcome is the result of a single trial, such as spinning a wheel, flipping a coin, things like that. The outcome is the result. The sample space is all of the possible outcomes. The event is any outcome or group of outcomes. And the favorable outcomes is the outcomes that match a given event, or that match a specific type of event. So when we are looking at probability, the probability of an event, or P with parentheses, the event, it tells you how likely it is that an event will occur. So that P with the parentheses event, that is the common way to write out the probability. You can find the probability by reasoning mathematically or by using data collected from an experiment. When all possible outcomes are equally likely, you can find the theoretical probability. And this is kind of how we view probability. The probability of an event happening is the number of favorable outcomes over the number of total possible outcomes. So for example, if I am looking at rolling an even number on a die, if I think about the numbers on a die, it's 1, 2, 3, 4, 5, and 6. And the even numbers, there are 3 of them, 2, 4, and 6. So 3 out of 6, or 1/2, would be my probability for rolling an even number. Which brings me to my last piece here. You can write the probability of an event as a fraction, decimal, or percent. Probability is always the likelihood that something will happen, but it is written as a number between and including 0 and 1. So if we're writing it as a fraction, that's obviously between 0 and 1. If we are writing it as a percent, we just need to remember that percent is out of 100, and so still between 0 and 1. So when we are looking at that, anything closer to 0 is less likely, and anything closer to 1 is more likely, getting all the way up to the certain where it's going to happen every time. So for problem number 1, finding the theoretical probability. Our solar system has 8 planets. In order of least to greatest distance from the sun, we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We are going to randomly draw one of the names of the planets, and we need to write a report on that planet. What is the theoretical probability that you will select a planet whose distance from the sun is less than Earth? So I am looking for the probability of the event where it is less than the Earth's distance from the sun. So again, I'm thinking about the number of outcomes that fit my criteria over the total possible outcomes. When I think about my planets, there are only 2 planets whose distance is less than Earth from the sun, and there are 8 possible planets, so my probability simplifies to 1/4. So the probability of selecting a planet whose distance from the sun is less than Earth is 1/4, or 1 out of 4 times. Alright, here is your got it. Please pause your video, try the got it, and when you are ready to check your answer, please resume. Alright, welcome back. Here is the answer. The answer for this got it question is 5/8. If you do not understand how to get that answer, please raise your hand and I will help you. Moving on, we've got another vocabulary word here before we go to problem 2. The complement of an event are all the outcomes in the sample space that are not in the event. So the extras, the pieces that do not fit the criteria. So when I'm looking at the complement of event, the sum of the probabilities of the event and the complement should be equal to 1. And so what I can do is, in order to find the complement, I can use what you see here on the last line right now. The probability of the non-event is equal to 1 minus the probability of the event occurring. So if I take a look at problem 2 here, in a taste test, 50 participants are randomly given a beverage to sample. There are 20 samples of drink A, 10 of B, 10 of C, and 10 of D. What is the probability of a participant not getting drink A? So in order for me to figure that out, I am going to do 1 minus the probability of somebody getting drink A. And that will tell me what's the probability of getting not A. So when I look at that here, I'm going to do 1 minus, and what is the probability of getting drink A? Well, it does say that there are 20 samples of drink A, and then I need to figure out how many total drinks possibilities there are. There are 20 for A, 10 for B, 10 for C, and 10 for D. So 20, 30, 40, 50, which is the same as 2/5. So then I need to do 1 minus 2/5 to give me the non-event or the complement probability, and 1 minus 2/5, 1 is the same as 5/5, so when I subtract that, I get 3/5. So the probability of not getting drink A is 3/5. All right, go ahead and take a look at Got It number 2. Please pause once again, and when you are ready to check your answer, please resume your video. All right, welcome back. Here is your answer. The answer will be 1 minus 20 over 50 plus x, where x is the number of samples added. So in this particular Got It, please make sure that if you don't understand where all that information is coming from, that you raise your hand and ask. The probability of not getting drink A increases. All right, so when we look at probability, we also oftentimes hear somebody talking about the odds. The odds describe the likelihood of an event as a ratio, comparing the number of favorable and unfavorable outcomes. So when we're looking at the odds in favor of an event, looks pretty similar. Number of favorable outcomes, but now this time notice the wording of the denominator changed to the number of unfavorable outcomes instead of the total possible events here. Odds against the event is the same thing, but the fraction is the reciprocal or is flip-flopped. So when I am finding the odds, what are the odds in favor of a spinner landing on a number greater than or equal to 6? So when I look at the odds of me getting something greater than or equal to 6, that would be 6, 7, or 8. So there are 3 possible outcomes there, 3 favorable outcomes. And to find the odds on the denominator, I'm not counting that I have 8 spaces on my spinner. I'm counting the number of events happening that do not fit the outcome I am asking about. 1, 2, 3, 4, 5. So my answer, my odds are 3 out of 5 or 3 to 5. All right, Got It number 3. Take a look. When you are ready to check your answer, please resume the video. All right, welcome back. For Got It number 3, your answer to Got It 3 is 3 to 1. Once again, if you need help understanding where that came from, raise your hand and I will help you. All right, so another thing that we need to understand, experimental probability is based on data collected from repeated trials. So this is no longer just in theory, but this is actually experimentally what would happen. So we're looking at the number of times the event occurred over the number of times an experiment is done. So after receiving complaints, a skateboard manufacturer inspects 1,000 skateboards at random. The manufacturer finds no defects in 992 skateboards. What is the probability that a skateboard selected at random has no defects? Write the probability as a %. So, the number of times the event occurs. What is the number of time in this problem that the skateboards that were looked at did not have any defects? 992. What is the total number of skateboards examined, or the total of number of times the experiment is done? That was 1,000. So I have 992 over 1,000. Now, in this one, it wants me to write it as a percent, so I am going to start off by going to a decimal. And then I can make that, into a percent pretty easily. So 99.2% of the time, the skateboards that were examined had no defects. Once again, pause your video, try the got it, resume when you are ready to check your answer. Alright, welcome back. Your answer for the got it question is 98%. Once again, if you need help figuring that out, raise your hand and let me know. And last but not least, problem 5, using the experimental probability. You ask 500 randomly selected household guests in your town if they have a dog. Of the 500 households, 197 respond they do have a dog. If your town has 24,800 households, about how many are likely to have a dog? So what's the application here of taking a small sample group and then relating that to a larger set of population here? So the number of people that own a dog was 197. The number of people they asked was 500. That is the same as 0.394, and I can divide that in a calculator to figure that out if I need to, which is the same as 39.4%. Now, if I'm trying to figure out, okay, well, my population is 24,800, how can I use my small sample group to make a prediction about my larger group? I can take my decimal or my percent, they are the same thing, 0.394, and multiply that by the number of people, or the number of households, sorry. So 0.394 times 24,800 gives me 9,771.2. So approximately 9,771 households in this town would own a dog. Now, notice in this question that I did round down. It's because we're not going to have 0.2 of a household owning a dog, most likely at least, and so rounding that to a whole number to get an estimation that makes sense. Alright, here is got it number 5. Once again, pause when you are ready to check your work. Please resume and check your answer. Alright, welcome back. Your answer for the last got it here. This is your last got it of your last lesson. Your answer to this one was 34,995 light bulbs. So if you need help figuring out if you got the answer wrong and need help figuring out why, please let me know. Otherwise, you are done. And here is your gift on your last lesson. No homework. Instead, please take a picture of your notes paper as if it were the homework assignment and turn that in on Canvas. And please, please, please spend your time that you would normally spend on homework preparing for the final exam.